Hey guys, how we doing? Let's take a look at our homework for this week. So, finishing up a few ideas from Unit 2. So, first thing we're looking at is least common multiple. So, what does it mean to be the least common multiple? Well, if you remember from class, one of the first lessons of the year, those frogs jumping on the rocks, right? So, one frog jumped on every second rock, one frog jumped on every third rock. What was the first rock they both jumped on together? That was kind of our visual the curriculum started us with. So what we can do that mathematically is if 4 and 10, if I jump on every fourth rock, I'm going to jump on rock 4, 8, 12, 16, and 20. If I jump on every 10th rock, I'm going to jump a lot farther because I go from 10 to 20. Least common multiple, the LCM, is the smallest, the least, common number they both share that's a multiple of both those numbers. So in this case, 20 is the first number that we get to if I like my multiples of 4 and 10. So that's why 20 is the LCM. So yeah, you're just going to write the multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, and so on. 6, 6, 12, 18, so even if we start those, so we got 5, 10, 15. I don't think we've got anything that 6 would be a multiple of either. So 6, 12, 18. So far there's no numbers that share. So just keep going until you get to the first number that they both share. 2 and 7. 2, 4, 6, 8, 7, 14, 21, 28. What's the first number they both share? Number 2, we're just adding and subtracting with unlike denominators. Again, in class I said it sounded like a broken record, I'm sure. What are we doing here? Sound like a broken record, right? It's all about common denominators. There we go. My Chromebook was sitting on my computer, funny. So we got to get common denominators. That's all we got to do is get common denominators. So if we take a look at 4 and 10, we can see that they got to 20, right? 20 was our common denominator. So let's zoom in a little bit here. So 4 and 10, we see that 20 is the first common multiple. Hey, you know how we just had the LCM? That's why we do that in class, guys. If I'm getting common denominators, the easiest, the smallest numbers is going to be the least common multiple. So we're going to use that idea of, how can I get these as something over 20? Well, 4 times what is 20? 4 times 5. So I have to do the same to the top. 3 times 5 is 15. 2 times 10, that's 20. So up top, we got to do 7 times 2, which is 14. So now we have 15 twentieths minus 14 twentieths. Now that we have common denominators, we can just add or subtract. We got 1 20th left over. So that's why we start by finding the LCM, and then we use that to help us get common denominators. Now, number 3, they're asking for the greatest common factor. So now this is a little different. Factors are the smaller numbers that we multiply to make up these numbers. So for number 3 here, the first one. So let's list our factor pairs. So we know we have, 1 times 16. That makes 16. How about 2? Yeah. 2 times 8. 3 doesn't work. And then 4 times 4. So those are all the factors of 16. Just start at 1. Go one number at a time till you loop around. Because 4 didn't work. And then 5, we don't need to keep going because it was 4 times 4. So we're good. How about this one? 1 times 28. 2 times what? Okay, 2 times 14. How about 3? 3 work? No. Okay, final 4. 4 times 7. 5 doesn't work. 6 doesn't work. And we already said 7, so we know we're done. And then what was the largest number that they both shared? It is indeed the number 4. So for factors, it's kind of the opposite of our multiples. And we've been talking about factors for quite a while. Factors are the numbers that make up our smaller numbers there. So for 15, we got 1 times 15. 2 doesn't work. Let's see, 3 times 5 works. Okay. And then do the same for 36, and then just find the number that's the largest that they both share. That's all we're thinking on that. Now we need to find the simplest form of each fraction below. Now, if you want, I'll go over a couple ways we could do this. If we know the greatest common factor, that'll help us get to our answer a little quicker. So let's start by not doing that. Let's just say, hey, you know what, these are both even. I can divide by 2 on these, right? Yeah, I can actually start with any factor that they share. So what if I divide both these by 2? Well, 16 divided by 2 is 8, and 28 divided by 2 is 14. Cool. Are we in the simplest form? Well, no, they still have a factor that they share, right? They're both even, so we can divide by 2 again. Okay, so divide both these by 2. Let's see, 8 divided by 2 is 4, and then 14 divided by 2 is 7. Are we done? Well, 4 has a factor of 2, but that doesn't work for 7. So these are relatively prime, because these two numbers share no common factors with each other other than the number 1. So we got there in 2 steps. But I also want to show you another way to think about this. If we start over, is what if we find the greatest common factor? So this time, well, for 16, I know 4 works, right? It turns out 4 is going to be the greatest common factor that they both share. So if we divide by that, 16 divided by 4 is 4, and 28 divided by 4 is 7. So here's the deal, guys. If you can divide by the greatest common factor, that largest number they both share inside, then that gets you there quicker. If not, just keep plugging away. It doesn't matter. Here's 2 ways we got to the same answer. As long as we know how to get to that answer, that's the main idea. So it's a little quicker if you know the greatest common factor, but just take any factor until they have no other factors other than one that they share. And then number 5, we have to add or subtract, but it does say use the information from problem 4 to help you. Well, look at this. How can we get a common factor or common denominator this time to add these? Well, let's see. We've got 28 and 14. Well, hopefully we just learned that or remembered 14 is actually a factor of 28, right? So if you can keep the larger number, if I can keep this 28, that'll make it a little bit easier because it turns out, yeah, 14 times 2 is 28, right? So I can leave 16 over 28 alone, don't need to change him. And then we said, hey, you know what, 14 times 2, that's 28. So we got to do the same up top. What's 2 times 2? That's 4. Okay, so now I got 16 28s plus 4 28s. Cool, common denominator. Now we can add or subtract straight across. 16 plus 4 is 20. So we got 20 over 28. Cool. So now we can just simplify from here. And let's see. Obviously, they're both even. They both have a 2. What about 4? Hey, 4 can go into both of these. So if I divide both these by 4, we're going to get 5 over 7. And again, they're both prime, so they're also relatively prime. They share no other common factors. So that's kind of the main way we've been talking about it in class. It's just if we can keep that larger number, go ahead. Now, we also start talking, we could also divide both of these. So some students are getting the hang of this and they want to say, you know what, can we simplify these first? Oh, can we actually make this something over 14? Or I'll let you take it from there, guys. But in class, this is the way we started, was keep the larger denominator if you can, and then simplify at the end. So as long as we end up getting to 5/7. Now in class, when we go over this, there'll probably be some students that didn't have 5/7, but they had something equivalent. Maybe they left it at the 20 over 18. Maybe they got a different number. But as long as it's equivalent, that's the right idea. And then we're just talking about simplifying from here. All right, number 6. Alicia says the greatest common factor of 8 and 12 is 24. So Alicia says the greatest common factor, the GCF, of 8 is and 12 is 24? Well, first of all, we can see right away we are going to disagree. Because factors have to be smaller than those numbers. Okay, what are the factors of 8? So real quick, let's just review. What are the factors of 8? Well, we've got 1 times 8. Sorry, sometimes my 8's on this pen. So we got 1 times 8, 2 times 4, 3 doesn't work, and then we already said 4, so we're done. How about the factors of 12? Well, 1 times 12, 2 times 6, 3 times 4, and then we looped around so we know we're done, right? Once we kind of loop around, we know we're done. So these are all the factors of these two numbers. Notice 24 is not written, right? Because 24 would be a multiple. So what is the greatest common factor? Is it 8? Nope, it turns out it's 4. So I'm going to say disagree because 24 is a multiple. Does it turn out it's the least common multiple? Yeah, because 24 is the least common multiple. Should have used the text tool for this one, right? So you don't have to read my chicken scratch. Least common multiple, the LCM, right? The greatest common factor or GCF is 4. So yep, so she made a mistake between least common multiple and greatest common factor. So again, least common multiple means I'm multiplying the number. So that'd be like 8, 16, 24, 32, right? 12, 24, 36, 48. I'm multiplying it to get larger. Factors are actually, we look smaller inside those numbers to see what are the smaller numbers that we can multiply to make up that number. So, yep, pretty common to get a little confused, but that's the idea. Felix says 11 over 33 is the simplest form. Do you agree or disagree? Well, I'll let you guys think about this one. Does 11 and 33, are there any common factors? If I have 11 and 33, is there any number we can divide by? Here's a hint. Maybe it's one of these numbers right here, right? So it might be 11. So I'll let you finish that, right? And then number 8 lists 3 examples when people need to add or subtract fractions in their daily lives. Great. In class, man, they were coming up with all kinds of great ideas, right? Go to is money, right? We're at the cash register. We got to get some money out. $1.50, you know. They said fill up their gas tanks. So you guys think anywhere in your real life that you're going to see some fractions, just think about it. Now, are we going to use our phones quite a bit to just kind of do it for us? Sure, but we're still adding fractions. And I'll even help you with this. Number 7 again. We can divide both these by 11. Even one of these numbers could be a common factor, so see what you get on that one. Okay, up next. Now we're dipping our toes into some Unit 3 stuff, and we're looking at how fractions and decimals can think of kind of the same thing a couple different ways, right? So this one, we don't have to actually add these up, but we see we have 4 tenths and 20 hundredths. And what's the big idea on this one is our place value chart. So if I have my decimal, we have tenths, hundredths, and then thousandths, okay? So tenths, hundredths, thousandths. So we'll take a look at this first example here. So we got 4 tenths plus 20 hundredths. Well, 4 tenths, that's going to be 0.4 because 4 is in the tenth spot. So it looks like it's this one right here, right? And then we also have 20 hundredths. Well, I need the 20 to end in the hundredths spot, so it's going to have to be right here. 0.20. Hey, and that matches right there. So, yeah. So then these two would be matches. So again, tenths, hundredths, thousandths. Okay, we're just looking at our place value. Once we have our decimal, we're going to be talking about place value. Whoops, let's not cross off our decimals, right? So we got our ones technically as well. Technically this would be our one spot, which we don't have any in these, but yep, cool. So that's the idea, is just lining those up. Again, if you have questions, let me know. We're going to be talking about this in class too. And then evaluate. Now it says a fraction and a decimal. So what we can do is just start by adding or subtracting with what they give us, and then we can convert it from there. So let's go ahead and look at letter A, 2A. So the biggest thing is with decimals, line up the decimals. So we've got 0.60 or 60 hundredths. We could also just think about this 6 tenths. But they give us 60 hundredths, and partly because we got 25 coming up. Let's expand this just a little bit. Let's say that they gave us 6 tenths, because it's the same as 60 hundredths. The 0 didn't change anything. And now we're going to subtract 25 hundredths. If there's nothing here, you can put a 0 here anyway. So they gave us a 0, but we can still think about just putting a 0 there if we want. Well, 0 minus 5, can't do that, right? So we're doing a lower grouping. Got a 5 here and a 10 here. So 10 minus 5 is 5. 5 minus 2 is 3. We have our 0. So in decimal form, this would be 35 hundredths, right? Tenths, hundredths, 35 hundredths. When you say the decimal name, you're really also kind of just saying the fraction name, right? If I say 35 hundredths, that also means 35 over 100. Now, I know we're also used to kind of simplifying our answers. This case, we don't want to. We're going to leave it like that because that shows us how equivalent they are. I could say 35 hundredths as a decimal or as a fraction. So for 2A, there you go. And that's it, guys. Line up your decimals, add or subtract. Now, how about, let's go over to F, just to give us a little space. 9 tenths plus 30 hundredths. Well, we got to get common denominators, right? And we can go either way on this one. We'll keep with the strategy, keep the larger denominator if you can. That's fine. So we can keep this 100. And in class, we'll talk about, we could go a different way if we want to. That's going to be 10 times 10 and 9 times 10. So that's going to be the same as 90 hundredths. So we got 90 hundredths plus 30 hundredths. Well, now we can add. So that would be 90 plus 30, 120 hundredths. Now, since we have an improper fraction, we could also think about how can we simplify that. So technically 120ths, or 120 hundredths, there we go. It'd be like 120 pennies, right? We got over $1. And then we could just, anytime we want to simplify an improper fraction, really it's just 120 divided by 10. Well, how many times is 100 going to 120? One time. Subtract. And then we got 20 out of 100 left over. So we can think about that as 1 in 20 hundredths. Again, keeping it kind of in that form because of our decimals. And again, 90 out of 100 plus 30 out of 100. We can think about that as 90 cents plus 30 cents, right? So we're going to get a 0, get a 12. Well, I guess I don't really need to carry it because we're done. But just make sure we line up that decimal, right? So we can see 1 in 20 hundredths could look like a decimal or a fraction. Either way, we get 1 in 20 hundredths, so they are equivalent. So, cool. All right. Well, I guess the answer key does simplify these. So we'll talk about that as well in class. So this 35 over 100. we know we can divide by 5, right? So 35 divided by 5 is 7. How many times is 20 going to 100? How many times is 5 going to 100? 20 times. So for A, our fraction in simplest form would be 7/20ths. Decimal, there is really not a simplification. It's just what it is, right? And then how about over here? Let's do the same thing. If we had 1 and 20 hundredths, well, we can divide it by 20, right? So if we divide both these by 20, 20 goes into 20 one time, and 20 goes into 100 5 times. So 1 and 1/5 would be our simplest form, but the key is understanding how we can think about that as 1 and 20 hundredths, okay? So line up your decimals, get common denominators, and then just kind of go from there. All right, reviewing a little more from Unit 2. Students at Jonah School can walk or run laps at recess at the end of the month. The class has covered the most distances recognized by the parent group. All right, so Jonah and Haley walked 4 1/3 laps around the track yesterday and 3.5 laps today. How many laps did they walk together in the last 2 days? We just need to add these up, right? So 4 1/3 plus 3.5. Gotta get common denominators. Again, broken record, right? In this case, 6 is going to be the least common multiple. So we can write these both as something over 6, because 3 times 2 and 2 times 3. Do the same up top. So 1 times 2 is 2. And up here, we got to multiply by 3. 1 times 3 is 3. So in other words, 1/2 and 3/6 are equivalent. Okay? Same with 1/3 and 2/6, technically. Yeah, they're both. We'll keep our whole numbers. Now we got common denominators we can add. So 4 plus 3, we see that our whole number is going to be 7. We had 6, so it looks like we got to add 2 plus 3. Let's see what we get there. And then it would be laps for the label, right? So go ahead and finish that up. We got 2 plus 3, boom, right there. Now Jonah ran 1 3/4 laps on Monday, 2 3/10 laps on Tuesday, and 6 1/5 laps on Wednesday. How much farther did he run on Wednesday than the other 2 days combined? So they're telling us that, okay, so we know Wednesday he did the most. So Wednesday it was 6 1/5. Okay? So we know that. And we're comparing that to Monday and Tuesday. So on Monday it was 1 3/4. Tuesday it was 2 3/10. All right, so, well, we already know that this is going to be more. So basically, oops, let me do that. So we're going to have, come on now, pen. We're going to have to add this first, and then once we know that, we're going to subtract it from the 6 1/5. So this is our kind of our big math problem we're doing here. What's our common denominator? Well, can we keep the larger number? Can we keep the 10? 5 times 2 is 10, but it doesn't work for 4. All right. Well, 10 plus 10 is 20. That'd be the next number we could try. Does 20 work? Yeah. 20 works for all these. So 6 and something over 20 minus, and then our parentheses here, 1 and something over 20 plus 2 and something over 20. Okay? So now we got common denominators. Okay, let's figure out what our numerators would be, right? Well, 5 times what is 20? 5 times 4. So I gotta do the same up here. How about over here? 4 times what was 20? 4 times 5. Gotta do 3 times 5, okay? 10 times what? 10 times 2. So 3 times 2. Okay, so do your numerators. We're gonna have to add these together. And then we're gonna have to take this and subtract it. Now you might notice that it might not quite work out that way. We might have to do some regrouping here. So let's keep going a little bit. So we got Well, so I want you guys to take it from there. If you have any questions, just reach out. But once you get this far, you're mostly done. Then we might need to do a little regrouping. Okay? But that's the idea, is getting common denominators. All right. Jonah and Haley made some brownies for the class treat. Some were plain, some had sprinkles. The class ate 3/4 of one pan and 1/6 of another pan of the plain brownies. They ate 5/6 and 1/10 of the other pan with sprinkles. So if the brownie pans were the same size, did the class eat more plain brownies or more brownies with sprinkles? And then how much more? Show your work. Okay, a lot going on here. But we got a couple things going on. We got some plain brownies. And we got some brownies with sprinkles. So first, we're going to have to figure out how much they ate altogether. So let's go back to the plain brownies. They ate 3/4 and 1/6, right? So let's go back and, look at our information here. Those are the plain. And then how about sprinkles? They ate 5/6 and 1/10 with sprinkles. Okay, so we got 5/6 plus 1/10. Cool. Okay, so that's the first part, right? We got to add our 2 plain brownies we ate, add our 2 pans of sprinkled brownies. Then we'll be able to compare. So we got to start here, guys. Now, we're going to have to get a common denominator. And my strategy, let's just get a common denominator for everything out of the gate. So 4, 6, 6, and 10. Those are our denominators. Well, is 10 going to work? Nope, not for either. 20, okay, that would work for 4, but not 6. Add another 10. 30, well, 30 would work for 6, but not 4. 50, we're going to go all the way to 60 on this one. So if we rewrite these as something over 60, so all we're going to do is rewrite these as something over 60. Okay, so 4 times what is 60? 4 times 15. So I can do the same up top. 3 times 15. It's going to go there. Okay, 6 times what? 6 times 10. 1 times 10. Make sure my chicken scratch is legible here. So again, all we're doing is getting common denominators, kind of cutting these into smaller pieces. So 3 times 5 is going to go there. 1 times 10 is going to go there. Then I can figure out how much plain we had altogether. And then over here, for our sprinkles, well, again, 6 times 10. So 5 times 10, that's going to go there. And then 10 times 6 and 1 times 6. All we do is get common denominators, guys. That's it. Write your new numerators. We'll even continue on that, right? So 3 times 15 is 45. 1 times 10 is 10. So now I can add up these to figure out what was my final total with plain brownies. Something over 60. Okay, how about over here? 5 times 10 is 50. 1 times 6 is 6. Well, 50 plus 6, boom. 45 plus 10, boom. Then we'll know, okay, how much total of the plain brownies did we eat? How much of the sprinkles did we eat? So then we'll know, A, which one did they eat more of, and B, how much more did they eat? Once you do this last step, it's going to be pretty easy, guys. So again, if you need some help with that, I got you that far. But reach out if you still have questions after that. All right, next we get to some pizza problems. Coach took his team out for pizza. So we got 14 players on the team. So the way it works is they just sit into 2 different groups of the tables. So 6 players sit at one table, and they get to share 4 pizzas. So we got 6 players at this first table, and we ordered 4 pizzas for them to share. Now over here, we had 8 more players at a little bit bigger table, and we gave them more pizza because there's more, and they got 6 pizzas to share. So the question is, did they get the same amount? Because afterwards, one of the players said it wasn't fair because some kids got more pizza than others. Do you agree? Use numbers, words, or labeled sketches to find your answer. Hey guys, this is just like the cans. Which can is a better rate, right? We're just comparing. Instead of dollars per cans, it's pizza per players. So what I would do is compare the ratios. Like I said, that was your hint. Let's get a common denominator. Well, 6 and 8. Well, 8 can't stay. 8 plus 8 is 16. That won't work. How about 24? Yeah. So if we write these as something over 24, 6 times what is 24? 6 times 4, right? Okay. And then 8 times 3, and 6 times 3. So if you get a common denominator, now you can really compare. And you're going to find out they're not the same. And then just think, would it be more fair if we had more pizza per player or less pizza? So with the cans earlier this year, we wanted the lowest one because it was cheaper. But if you're eating pizza, you probably want the one that has more pizza per. So we'll talk more in class, but again, just compare those ratios. All right, candy sales. All right, we get to a graph here. So first of all, it just says, we're helping at the concession stand, and the lighter gray is the first game, the darker gray is the second game. So we're comparing our concession sales between two different games. And let's just jump down here real quick. We see we're looking at bubblegum, some hard candy, and some sour strings. Okay, and we can see there's numbers. Okay. Let's take a look at our questions. So look at the information for bubblegum. So number 1, we're just looking at bubblegum. What was the profit for the game 1? What was profit for game 2? How much more profit was made on bubblegum during game 2 than game 1? So first of all, one observation we can make is look at this chart in general. We have our first game, second game. First game, second game. First game, second game. Can we clearly see, did we sell more candy during one of those games? Did I sell more gum on the first game or the second game? Hard candy, sour strings. Well, we can see the second game is way higher, right, than the first game on these. So maybe we had more people. Maybe it was a bigger game. Cool. So just some general observations. Now, let's start getting a little more technical here. So the question 1, we're going to talk about bubblegum. So what was the profit for bubblegum during game 1? What was the profit for game 2? And then how much more did they make on game 2? All right, let's zoom in on this. So looking at bubblegum, we see $1, $2, $3. So these darker lines are the dollars. But they broke this up into, I got like 1, 2, 3, 4. If they take that dollar and they break it up into 4 parts, hey, that's like quarters, right? So that means each one of these lines is a quarter. So we got 25 cents. Actually, I'll go a little bit thinner with my pen here. So we got 25 cents. We got 50 cents. We got 75 cents. And then we have $1. Okay, so each one of these is a quarter. So let's take a look at this. So we hit $1, and then 25, 50, 75 cents now with $1, right? So each one of those lines. So that means this stopped at $1.75. Okay? How about here? Well, we hit over $3. We didn't sell $4, but we hit more than 3. So $3.25, $3.50. So there, just based on that, we can start answering these questions. So it's $1.75 and $3.50. So what was the profit for bubblegum during game 1? $1.75. Game 2, we said it was $3.50, right? So it's $1.75 and $3.50. Okay. How much more was made on game 2? Hey, what did we just say about decimals? Just line them up. So $3.50 minus $1.75. If we're looking for difference, that's one way to do it. You have to do a little regrouping, go from there. Then number 2, how much more profit was made on hard candy during game 2 than game 1? So number 2, we're going right to hard candy. But instead of listing both of them, how much more was made? Well, let's go ahead and finish. We'll kind of fill out this chart a little bit. Let's look at hard candy. For game 2, we can see that was exactly $8. Right, so we made $8 on hard candy. And then how about game 1? $4 and one more quarter, so $4.25. So we can figure out what that difference is. And then number 3, how much more profit was made on sour strings on game 2 than game 1? Okay, let's go over to sour strings. First game for sour strings, didn't quite make $3. We hit $2, $25, $50, $75. So we hit $2.75. And then how about the second game? We made over $8. In fact, one more quarter, so $8.25. So now that we know these numbers, now we can set up your problems to find the differences. And then finally, the question 4 was, how much greater was the profit from all the candy sales from game 2 compared to game 1? Okay, so then we need to look at all 3 of those candies and how you did during game 2 versus game 1. A couple ways you can handle that. I'll let you take it from there. If you have questions, let me know. And then last page, right? Sweet. Just some good old orders of operation. Guys, orders of operation is such a cool concept. It's fun. You get to kind of play in it. And if you can do these successfully, not only do you know the orders of operation, but you know all your basic facts to get to the final answers, right? Now, we also learned technically in our first unit, if we're just multiplying, you don't have to follow the rules here, but you can. Now, B, since we have multiplication and division, now we do need to follow the rules, okay? Because we said if we're just multiplying or we're just adding, you can go in any order. But if we got more than one thing going on, we do got to follow the rules. Same with C. Let's take a look. We got something inside here, something inside here. So start inside your parentheses. And one thing we want to talk about is, again, PEMDAS. We do start inside parentheses. We haven't really talked much exponents yet in 5th grade, but that multiplication and division, they're on the same level, right? You multiply or divide left to right, right? So don't always just multiply first, and then same with addition and subtraction. Addition and subtraction are on the same level, left to right, okay? So just keep that in mind, okay? There's not a ton on these, but parentheses, exponents, then multiplication, division are on the same level. Go left to right. Once you're done, finally the last step is adding, subtracting, but going from left to right. 6, Trina said $1.05 plus $2.25 is $3.75, because $1.02 plus $2.25 equals $3.75. Okay, that's a lot of words for me too, right? So just think about it. We've got a couple things going on here. We've got this right here. We're looking at this, but then also we got a few other things. So we got $1.02 plus $2.25 equals $3. Yeah. So just tell me what you think. Help Trina out here. See what you think. We're going to talk about it in class, guys. Last, again, what do we got to do? Line up your decimals. That's it, guys. So I'm going to always rewrite these stacked on top of each other. Line up your decimals. So I already know my decimal is going to go here, right? So just line up those decimals, carry over numbers where you need to. Same with this one. $5.01 plus $5.10. Well, looks like we're going to be at $10, right? 10 something. So you can always think about this as money if you want. But again, line them up, line them up, line them up. Line up those decimals and go from there. And again, this wasn't even a challenge, guys. We talked about this so much in Unit 1. We got a box that holds 580 baseballs. Now, each layer has 18 baseballs in it. How many layers does it have? So we're not sure how tall this box is, but we know each layer has 18. We got another 18. We got another 18. How many stacks of 18 do we need to get? We're not sure how tall this box is. But how many 18s will it take us to get to that 540? Good old division. Just start dividing. Guys, we're rocking. We're getting into Unit 3. Keep up the great work, and just reach out if you have any questions, guys. That's my job, is to help you out. Have a good one.